hearty welcome to Research Live. For today, we come to talk about a very interesting topic, and this is something that we've gathered after a series of discussions with early career researchers. Now, just before I kick off, I'd like to start with this interesting quote from Albert Einstein, and it goes like, if we knew what it was we were doing, it will not be called research. And I think that depicts our topic for today very nicely, in that developing research ideas happens to be a key challenge that faces researchers, particularly early career researchers. And to help us address the issue today, we have a world-leading researcher, Professor John Sumpter. Professor Sumpter's research group depicts fine research excellence. And in recognition of this, Professor Sumpter and his team were awarded the 2011 Queen's Prize for Higher and Further Education. This prize happens to be the most prestigious prize open to academics in the UK. Professor Sumpter is a recipient of grants totaling about £5 million and has supervised to date about 25 PhD students. So we are in very good hands. Good afternoon, Professor Sumpter.
Afternoon,
and thank you very much for accepting our invitation today.
It's nice to talk to you.
I'd like to take you back a few years, yesterday, and to tell us about how you generated your first research idea. How did this happen?
What I would say is that it's almost impossible to think absolutely originally. So there are not many Einsteins around, so probably most people should realise that it'd be nice if there were a few more Einsteins, but they're not going to be an Einstein probably. So what most people do is they base their ideas on what they've already learned. So if you looked at the career of almost any established scientist, what you would find is what they're doing now, you could essentially track it back. And you would find that, let's for example say they were interested in cancer in their PhD, it's quite likely they'll still be working on some aspect of cancer even when they're a very independent scientist. So and what this means is that who you work with and how well they inspire you is extremely important. So if you look at the careers of some of the best biological and clinical scientists that I've heard of, almost all of them worked with world-class people, and almost all of them have then followed that line of research, if you like. So you could say perhaps they haven't thought quite as originally as you might imagine. So it's almost unheard of to think of someone, for example, who was trained in cancer and then became a conservation biologist interested in the genetics of elephants in Africa or something like that. So that degree of original thinking where people move from one area to another, there are a few people that can do that, but it's extremely rare. Most people build on what they've learned and try and project into the future and say, well, if we knew this, or if we could do this, we would move forward. And that's how the majority of people think.
Okay, so having said that, in the context of what you're already doing, how do you sort of come up with the incremental idea, so to speak?
I would say for me, I have a sort of what you might call a higher level question. So in my particular case, it might be that all of us use lots of chemicals in our everyday life, and they end up in rivers. So my question is, what if anything do those chemicals do to fish? So that's my sort of higher level question. And then I try and break that question down into chunks that you can do and deliver. So that's essentially my strategy. And then I have a fairly logical, I go step by step. I don't try and go from here to here in one leap. That's what Einstein did. I'm not like that. So I go like this, trying always to build on what I've done, but looking into the future and saying, if we knew that, we would be better informed and more able to answer that particular question or find a solution to that particular problem. So it's that, to me, it's quite a logical process.
And let's consider a situation like you've come out with the first pack of the idea. What do you do now? Do you talk to other researchers? Do you talk to your colleagues? Or you just plunge yourself straight away into the literature to see whether somebody might have put you the idea?
I'd probably do the latter first. The one thing I would say to anybody doing research is never be frightened of the competition. You can spend your whole life worrying about someone else, whether they're going to beat you to it. And if you do that, you'll probably never do anything at all. So I would say, don't worry about the competition. Think of your question, preferably a hypothesis. The best way to do science is to have a hypothesis and then say, can I design some experiments, in my case, to test that hypothesis? Definitely know the literature, absolutely know the literature. So you can almost not spend too much time knowing the literature. But I'd also say, don't be frightened about talking to other people. Don't be concerned that they're going to steal your idea. Lots of scientists think that other people are going to steal their ideas, and so they won't talk to other scientists. That to me is not what science should be about. And personally, in 35 years of research, I can't think of a single example where I would say, oh, that person stole my idea. I might have influenced their research and they might change the direction of their research a bit in the direction that I'm interested in, but I can't think of a single example where I really sort of resent that someone's taken my idea. But I can think of many examples where by talking to people I've established collaborations, and those collaborations mean that more minds are applied to your hypothesis or question, more research will get done on it and it'll move it forward faster, and that's what it should be about.
So how would you advise they manage the conversation, which might have two contradicting objectives? One, to come with useful input, as you've rightly indicated, and on the other side, to still protect the intellectual property right?
I personally, I'm not too concerned about the competition. I'm not too concerned about sort of protecting my own ideas or something like that. I would be very open and honest with people. Now, this sometimes means that they'll turn around and say, well, if you knew the literature, John, you wouldn't think that. Or they might turn around and say, someone else has done it already, or we're doing it, or something. And sometimes this happens, but more often than not, they say, that's quite interesting. I think this and this. Could we collaborate on this bit of it? So I've tended to share my ideas and also actually share the techniques I've developed as well. So I've given them widely to other scientists, some of whom then use them to compete with me, but I don't feel threatened by that. I think that's how science should progress, and it moves science forward fastest. So if you protect things and you shelter them completely, and so you feel they're yours and nobody else, apart from which that might indicate some insecurity scientifically, probably won't help science a great deal either.
Okay. Some of the researchers we talked to said they struggle with how to assess the feasibility and whether the ideas are worth pursuing. And we wanted to find out whether, how have you done this?
It's a tricky one. To some extent, you don't know whether the idea is worth pursuing until you pursue it, of course. Because as you started with your quote, if you knew what the research was going to tell you, I probably actually I disagree with Einstein. I'd say it's still research. But if you knew what the outcome was going to be, then you might actually say, well, almost, is it worth doing at the end of the day? So I tend very much to say, I think this is the piece of the jigsaw, if you like, that we don't know. I'm not frightened about trying to do something where other people, it's happened many times in my career, they've said to me, I don't think that's possible to do that yet, or we don't have the techniques to do that, or the background knowledge is not available to do that. I've always found that a challenge, that if there's one thing that's going to make me go down a certain path, it's other people tell me that you can't do it. So I tend to decide what I think is worth doing and try my best to do it, even though sometimes you don't do it as well as you'd like to, or it doesn't turn out quite like you want it to, but you still start to move the research down one particular area. So I'm not that concerned about it can't be done, the technology's not available to do it like some people are, and I've had many grant applications rejected on the grounds of, including sentences like, I don't think this can be done. Sumpter couldn't, nobody could do this, Sumpter couldn't do this. So I still think the right thing to do is to have your question, your hypothesis, and go for it, basically.
Once you have a pool of ideas, let's say 3, 4, 5, how do you prioritize?
You might, I think you'd put it sort of, I personally would prioritize on the grounds of which do I think is the most important. So if one was going to save British fish and the other was going to save the world, I'd try and save the world. So I would sort of prioritize them, I would rank them on which I thought was the most important question to move me the furthest forward. I wouldn't rank them, or not to much of an extent, on, say, practicality or anything like that, which some people would. I would say, this is the question we really want to answer. This will move us forward the furthest and fastest if we can answer it. So it should be my highest priority.
How do you define importance?
That's tricky. I have, of course, some experience in doing research that's turned out, I don't know when I'd use the word reasonably important, but quite a lot of people have been interested. If you had have asked me at the time, John, here's 2 pieces of research you've done, can you predict which of the 2 will have more impact than the others? I definitely would have struggled at the time, but I probably still struggle now. It's not easy to know, in my opinion anyway. Having looked at some of the research I've done, seems some bits of it turn out to be of general interest to quite a lot of people, but other very good pieces of research, good in the sense I think the research was done well, it's reproducible and that sort of thing, but not many people are interested in it. So I think trying to predict what will be important, what will have impact, etc., in my opinion, that's quite difficult.
Okay. Now to the final question, and it's on the Queen's Prize. Can you tell us how that happened?
I think the first thing I would say is don't go into science. The wrong motive to go into science is to become famous, to win awards, to win prizes. Please, if you want to do that, go into the movies or something, but not science. To me, that's not what I do science for at all. I do science because of to some extent, the intellectual challenge. We don't know this, and I think it's worth knowing. So it's the sort of, we don't know, and then that's the intellectual side. And then I think if we did know this, in my case, it might improve the environment a bit. In lots of people's case, it might improve human health a bit or something like that. So I think the motives for being in science, in my opinion, should be absolutely nothing at all to do with fame or awards or prizes or anything like that. Do your best. Try and tackle important questions if you think you can identify them. It's a bit tricky. Do the best science you can, and it may or may not turn out to be reasonably important. And I think there's a lot of luck involved at all. A lot of luck. I know some people who I would say are very good scientists who haven't had much luck, in the sense they've done lots of science, but it hasn't had any sort of groundbreaking consequences. But there are other people who just stumble on something nearly always by accident, and they may not be the greatest scientists in the world, but they stumble on something that turns out to be quite important, and so they win a few little awards or something like that. But no, do science for science sake, not to occasionally meet the Queen.
Was anything different about that specific idea in relation to the others you've already pursued?
No, I think not, other than it turned out to be what we did turned out to be of much more general interest than we were. So we found a few so-called intersex fish in some rivers. So these fish were not male or not female, they were halfway in between. And we realised that chemicals in the water were responsible for essentially changing, feminising those fish. And when we did the research, we were doing it in a few reasonably polluted rivers in England. And I don't remember it crossing my mind. I don't remember thinking, this could be a worldwide problem we've stumbled over here. And that's where you get to the difficulty of predicting the impact of the research. So the biggest impact was, it turned out that firstly it was a worldwide problem, but more generally it told us that lots of chemicals that you and I use and excrete that go down a toilet, those chemicals will end up in rivers, and the animals that live in those rivers will be exposed to them and might be affected by them. And we worked on just one very small group of chemicals that feminise, but it was the general realisation that as society developed, we become more and more dependent on chemicals, and they don't go away when you wash your hands or flush a toilet or something, or have a shower or something like that. They might leave your house, but they're going to go into the environment, and they will come back to haunt animals in the environment and us in a variety of ways. So it was that it was the general information that came from the research. The research was quite targeted, but the general message was the important one, and that's what was important as far as the Queen's Award was concerned.
Okay. On that note, we'd like to thank you very much for accepting our invitation and granting us this interview. Thank you very much, Professor Sumpter.
Well, thank you too.